Hello, fellow Haskellers! Welcome to Haskell Mask, the show where Haskell something, but we don't know what, and so we're programming an AI to tell us what. Hello, Thurston, how are you?
Hi, I'm good. How are you?
I'm good. So last time we met, we had implemented the bridge between the Haskell and Rust part so that we can tokenize a string into numbers, I think.
Yeah, I think we managed to do that.
So what's next?
Um, so, right, so like, let me think. So I think we have finished the BART implementation, so the machine learning model we wanted to use for predicting text,
Excellent.
or in this case, Haskell code. But in order to use it, we need to combine it now with the tokenizer, because this allows us to go from text to what this model wants as input.
Mm-hmm.
And what we basically need to do is we just need to go into our code base and use the tokenizer there to do that transformation.
So what was that previously returning? Standing for tensor. So that produces the tensor. Oh, because we don't need to hold onto the tokenizer for the entirety of the execution of our model, only while we create the input. I see. Okay. So we call with tokenizer, get a tokenizer, and here create an encoding by calling our encode function. It's an IO function, so bind instead of let. Encode with the tokenizer. The input, hello, my name is Mask.
Mm-hmm.
And then, what is... It's an encoding. What is an encoding?
And encoding is something
It's a
we
wrapper
cannot
around
really
the
do
pointer to a C
yeah.
encoding. Okay.
Yeah, it's awesome. So I already see like another memory leak here, but let's
Okay.
just not worry about it. I think you want the last function in the module. It's called a get IDs.
List of IO ints. Now that's something I can do something with. So IDs, get IDs from the encoding, and we would like to do something like free encoding, but we don't have a function to do that. And now I should be able to call make BART input with that list. But this list IDs is not statically known to have size 7. Are you saying that there's no link between this type level length and this value level list? You just the compiler is trusting you?
So what will happen is it will just make a box of size 1 by 7.
Mm-hmm.
And then it's just taking whatever fits from what you write there as argument in that box. And if there's less stuff in the in your argument, then it will just invent stuff by padding. And if there's more stuff, then it will truncate.
Okay. The padding doesn't seem too bad.
The types are not safe, but
the padding approach doesn't seem too bad. Is it the padding number which will be recognized by the BERT model, or is it some different padding number?
It should be the correct one, because you see this make function has the word BART in it, right? So if you look at the implementation of this, I think it should use the BART padding token. Yeah.
Great.
So
so let's Well, 7
So I don't
might
know
be a
what.
bit too short, but let's try it with 7, and if it doesn't work, let's make it a bit bigger,
I
and
mean,
the worst case, they will
we
be too...
could just see
Oh,
insert
good
print
idea, yeah.
IDs. Yeah.
So, while we're waiting for stuff to compile,
Mm.
we only changed the test BART input. Should we try to do something similar with the output? We'll be getting back a bunch of numbers. Maybe we should try to decode them into text. What's your convention as to which direction is encoding and encoding? You said it was encoding to go from string to numbers, but I guess my intuition was the opposite. You're encoding. Oh, okay. Now it makes sense. The text is like the decoded, readable version, and the numbers is the encoded version. Okay, that makes sense. So let's decode the numbers into text. So where is that called?
So you want to go round trip and see if it's the same again?
That's not what I was thinking. No, but rather here. Test forward BART base is calling test BART input, so that exercises the encoder, and then it calls test BART decoder input. Not sure what to do about that. And then we're initializing the model. Oh, still with the an absolute path. Okay. So the script was already only working on your machine. Blah blah blah. We call forward, and then we get an output, and that's what I wanted to do with the output here. I wanted to decode it back to text, so that instead of getting a bunch of numbers, we get "Hello, my name is Bob." Right?
So that code doesn't do that. So like he skimmed over this one detail that was weird to you, and I think it should be weird from where you are in your thinking, that there is a second input for the decoder, right? You might think, why do we have that? If you want to produce, why would we need a input to the decoder? Because we want to get something out. We don't want to put something else in.
Yes, you explain this to me every time. Let's see if I remember.
Okay.
The decoder, we expect to call it several times with an input that is just blank, 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 and then hello, blank, 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 and then hello, my blank, 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 until eventually we have hello, my name is blank. And that's when it will reveal to us what is the word that it thinks the blank is. But for all of the previous ones, it also like double checks that it has correctly been trained or something, and that when it already knows that the sentence should be hello, my name, blah, blah, that when we ask it what is the word that comes after hello, my name, hello, my, it should indeed output name. So I guess we don't need to double check that it works for all of those other positions. So we could give it hello, my name is blank instead of hello, my name is mask. Right?
You could, yeah, and then you look at the last position and then you see what has the highest probability. We could do that. Yeah. We could do that, indeed. Yeah, so the question is now, like, I mean, we can produce one symbol, right? If you do that. So basically you would force the decoder to, I mean, it's sort of Okay, so like when you do this generation, you do this iteratively, right? So like you use symbol after symbol until the model predicts the end of sequence token, and then you
Ah,
stop.
in case instead of just predicting that it says hello, my name is Bob, if it predicts something longer like hello, my name is Indigo Montoya, prepare to die, end of sentence, uh, we'll generate each word one at a time until it says end of sentence. Okay.
Right. So maybe what we could do is maybe that's a good exercise actually. So I have implemented a generator for these sequence models, but this was some time ago, and I did this for T5. But I think greedy decoding is not that difficult to try for ourselves. So we could do it here and see what that gives us if you want.
Well, I feel like we should go
So
one step at a time. I was only suggesting to do something about the output because we were waiting for the thing to compile, but like writing this loop that makes the decoder, like the part of the decoder input gradually longer and picks the highest value, most probable symbol to be the next input of the decoder instead of the series of blanks, sounds like something that will take more than what I assume is a few seconds, because it says already 105 out of 105. So maybe let's just wait and then run it on that input and see what we get. We should be getting the exact same numbers as last time because it's the same input. It's just that instead of hard coding the numbers corresponding to hello, my name is Blask, we wrote the string hello, my name is Blask. Assuming I correctly remember that this is indeed the text that led to those numbers. I'm probably going to cut out large portions of this session when uploading to YouTube, but like I never know like which sections to cut out. Like long sections of cut out, long sections of silence, sure, but like when we're struggling for a really long time to find something whose answer turns out to be much easier than we expected, like well, it's always the case when we debug that in retrospect it looks trivial, but like is the struggle also interesting to watch, or should I just skip to the solution?
Yes!
Yay!
Ooh, okay.
However, it is
so what numbers?
the same numbers as we had before.
So we need to make the sequence 2 positions shorter. Right. And
are you sure?
then...
Don't we need a piece of padding?
No.
So the output doesn't have to be the same size as the input? Actually, come to think of it, how come we are allowed to choose the size of our input? Aren't we wholly dependent on the choice that were made by the authors of the BART model since we are loading their weights?
Not sure if I understand the question. So like, surely you can change the length of the input sequences?
Will
the weights
it be padded automatically?
So the sequence length, so the weights are independent of the length of the inputs.
Well, I remember you explained that one of the downsides of this kind of model is that the size of the input is limited. And so I had expected that we would have to provide an input of exactly that size. Presumably, we are allowed to provide an input of at most that size, and there's a step that pads it up to exactly that size by adding a bunch of padding tokens.
Yeah, so this is how it could work. It's not quite what happens. It is not padding up the input when it is shorter, but there's a positional embedding, and there's just 512 512 embeddings in that positional embedding, and each of the positions of these 512 positions corresponds to one token position in the input. So once you reach the end, right, of 512, so if you try to use an input that is 513 tokens long, that lookup in that embedding will fail, and you have a runtime error. So that's what defines the maximum.
Didn't quite get that. I remember that.
So you remember the positional embedding that we had to load?
Vaguely. Is it that
Vaguely.
for each of the numbers that we get after we call encode, that number is not directly an input in the sense of a weight, but rather we look up that number in a table of vectors, and that gives us a point in an n-dimensional space that is the input instead. But then that only gives us a point in the n-dimensional space for one of those numbers. Since we have up to 512 numbers, what do we do when we have more than one? Do we add those vectors or something?
I think now you lost me. So wait a minute. So let me take you to the code that's relevant for this. If I can find it. I guess it's a sequence. Must be. Sequence transform generation is the wrong one. So here's a nice diagram. Decoder position. Scaling. So the problem is that is happening in the encoder and the decoder independently. Right. Here we have what we need. Okay, so this is the code that does that. So we have so this is the encoder, and the encoder takes three arguments, input. So these are the numbers you were talking about. So like each index that we just got from the tokenizer is one element in that input tensor, and then we have this positional input, and this one has the same shape as this input typically. But instead of like having indices in it that corresponds to tokens, the indices in there correspond to where the tokens are in the input. So typically this is just like basically a sequence that counts from 0 to length of input -1, right? And then there's also this attention mass, but this is not relevant for what we're going to discuss. And the first thing that happens if we take these positional indices, and we are using as an input to this positional encoding here. So that is a dense weight.
Go on.
Yeah? Oh, sorry, I thought you wanted to ask something.
Well, I was about to ask
so
if it was again trying to look up for each of those numbers, not encoding numbers, but positional numbers, a point in ND space. But I think that's what you're about to explain, that no, it doesn't do that. Instead, it's a dense layer. instead of a lookup.
Yeah, it's an embedding, right? So like it is exactly what you just described. So it's basically a
Okay.
lookup table, and each entry is a vector, a
Okay.
dense vector of certain size. And that table has a certain size, right? And for BART, it happens to be 512. So if you send only positions between 0 and 511, there will be no problem. If you send larger position indices to that function, then you will get a runtime error.
Okay. So we have both a lookup table with 512 vectors and an even bigger lookup table with like 100,000 entries or something corresponding to the 100,000 possible tokens that are supported.
Mm-hmm.
Okay. And you said it was a dense layer. Is it just as opposed to okay, you said it was dense, but then you clarified it's not the layer that is dense, it's that the output is a dense vector, like as opposed to a one-hot encoding?
As opposed to a sparse embedding where not all positions in that vector are actually populated.
Okay.
They're not that popular
Okay.
because they're hard to use
Okay.
and not that much supported. Right, how did you get into this? Oh, because you were asking how can it be that we feed in a short sequence here? Isn't that model only made to process sequences of a certain length?
Mm-hmm.
And the answer is yes and no.
So I'm now guessing that we take each embedding of a token and we multiply it by the embedding of the position. So that gives us another vector, and I'm guessing we multiply all of the resulting, add all of the resulting vectors or something like that.
Yeah, we add.
Okay.
So you can see it. So like these vectors that come out there, they're added with the inputs. Right. Why
And
did I mention this?
If we were only adding all of the tokens instead of adding the tokens multiplied by the position, then any permutation of a sentence would look the same to the model, and so they would not be able to understand the structure of sentences. So it makes sense. Okay.
So what we wanted to do was we wanted to look at what the model predicts here.
Mm-hmm.
So so there is this encoder output, which is not relevant. There's decoder output, and I think this is what we want to look at. So we're already pulling out numbers here from this. So this is like a triply nested list of floats, right? So I think the first dimension, like the outermost, corresponds to the batch. Then the second outermost, which happens to be also the second innermost, is positions, counts positions. So the last element is actually the one we're interested in. And then the innermost list here counts over all possible token outputs. So I believe there must be like 50,000 or so numbers in that inner dimension.
I was off by a factor
so what we could do, the same order of magnitude. So what we could do is, well, we could like say here last logits, the first logits, and say, okay, I think there's just one batch, so let's just pick the same one here, decoder outputs. And then I guess last position. Do you know how to get the last one?
Yeah, there's a last function that takes the last entry of a list.
Oh, okay.
It's partial,
last.
not head.
Sure. Oh, but this is not a list monad anymore, I guess. And then we want to sort them, right? So do you know how to sort a list? Sort by? Okay. What does it take as arguments?
Well, here you
just
have a list of floats. So if you sort it, it will be sorted by that float, but we'll have no idea what is the index at which we had the highest value. So
we need something that
instead of sort by, how about maximum by? And the argument is an ordering, like a comparison function, I think.
Yeah.
So you can easily construct one of them using the comparing higher order function. So comparing, this is an idiom, comparing, which is the same as compare on, whatever. Comparing, and then a function that gets you the thing you want to compare on, which at the moment seems strange because, well, we only have a float. But what I had in mind is that what would be taking the maximum of is not the list of float, but the result of zipping our list of float with the list from 0 ... So this way we will.
We're not actually interested in the floats we're not interested in the floats themselves.
You are interested in the position, and that's what I'm showing you how to compute. We can zip our list.
So we want to have something like argmax, right?
Yes. But there's no argmax. I'm showing you how to build that one.
Okay.
So zip
range. No, what is it? 0.
0 ... Mm-hmm. And then that whole thing is what we are taking the maximum by of. So we're taking it, comparing the second position. So comparing S and D. Comparing is already a higher order function, so you don't have to write a lambda.
Okay. Go away. Sorry, this thing is somewhat laggy.
And now that will give you the pair, but I guess you're only interested in the index, so you can take the first of whatever maximum by returns. And there might be a maximum on that does comparing for you. It's from data.org, I think.
Okay. So I get some pure here. Oh, we went pure. Now I'm on list again. What is this thing? This is a list of integers. Do you want that? Sure, why not? That looks somewhat good, right?
But that will only give us a token. Can we decode that token?
Yes, we can. Right, so what we need to do is we need to use the tokenizers dot tokenize this dot decode, which take tokenizer as encode. So I guess we need the with tokenizer again. Right, so let's just stick this thing in and see what happens. Sludge it. So this goes now into nowhere, so I guess I could...
wait, so what's the input of decode? I would have expected it to be like the opposite of what encode returns, that is an encoding and not a list of int. Oh, it does take a list of int. So why isn't encode returning a list of int as well?
Because different people wrote encode and decode. Okay. I wrote decode, Austin wrote encode.
All right. So that will give us a list of strings, which we can print.
Yep. Which we can print. So wait a minute. So I guess I just do this.
Sure.
Let's hope this runs. This is called test forward BART base.
Both the audio and the, I guess, interaction with the IDE is much smoother in this mode in which you're sharing your screen instead of sharing a Visual Studio link with me. Maybe we should try that approach next time. It's a bit less interactive, but it works much better.
And I think I can be sure that you're seeing what I'm seeing, right? Which for me is sometimes also a bit odd because I don't know where you are. Are you actually know where I want you to be, or did you get stuck? Because I see it on Twitch only so much later, right? I would like to make this super large, just so everybody can see what's going on.
Chris! Yes, my name is Chris.
So I think
excellent. It works.
Yeah, I think. So how about we try something what we're actually interested in? Not how my name is. But
Haskell?
Haskell. So let's see. Hello, my name is 1, 2, 3, 4. Haskell's only 1. So I guess we have only.
Well, Haskell is not going to be encoded
4,
as a
right?
single token, is it?
I don't know. Let's see. I mean, I would encode it as a single token. It's super important to me. No, you're right. Like
several tokens towards the end. You said there was only 50,000. It's like the one of the very last numbers. 50,264.
Yeah. Okay.
Oh.
So,
or maybe it's the mask itself, which is -1. It's not Haskell.
Okay. So now Haskell. Let me just print this too, just to make sure. Hello. There's BART decoder input. Oh, now we have padding, so I only need 3. So Haskell seems to be split in 2. Don't ask me which one. Probably Has and Kel or something.
Yeah.
So I need 3 here.
No, I think you need 4. Don't you need to include an element of padding? No, we just discussed that.
No,
okay. Ignore me.
Wait, so let's run this again. See what's behind the mask. Yeah, it's bigger. Probably crashing now. Something super will happen.
Who is behind the mask? Haskell. Maximum margin of error.
So it is crashing, but only because
why?
because the numbers that are in there were made for the other input.
What?
Remember that I had this numerical check here? These numbers here?
What are those for?
They were such that I could find out whether the implementation was like identical to, like, was having the same effects as the Python one. And the example I tested this with was the hello, my name is Chris example. So we changed that to a Haskell, so of course the numbers will be different, so therefore the exception.
Darn. Yeah. There seems to be some connection issue.
Colon!
Colon!
What's happening?
So how do you...
Colon!
How did you fix the error so fast? I thought we would need to like get the corresponding numbers.
No, I just commented the assertion here.
Okay,
See
so
that?
Haskell colon. Okay, fine.
Follow.
So now I see why you wanted to write the loop to continue asking for more tokens until the end of sentence delimiter.
Well, I guess since we now know that it must be a colon here, could just
Yeah,
add
we can
the
do
colon.
it by hand. Yeah.
Yeah, I just do it like one thing at a time. You just need to recompile. Oh my God. Can you imagine what people would say if you had to recompile your program whenever you need to produce one more output?
Mm-hmm. Haskell colon end of sentence. That's it. Just Haskell colon.
Perfect. Okay.
Okay.
Sure,
Well,
why not?
that's the new name of the show. Haskell colon.
I mean, we could force it to do something else.
What's the second
Haskell
most likely?
Haskell is.
Ah, that's not the same.
Is A.
Yeah, a functional programming language. Yeah. Can we check what is the second most likely word to follow Haskell after colon?
What is A? That's weird. Oh, I forgot.
The size? Yeah.
Yeah, the size.
It's gonna say functional.
It's a language. Okay. So what do you want to do? You wanted to change.
Yeah, I still want
this
Haskell something instead of Haskell is a language. But since we know that it really wants Haskell colon, I was thinking, okay, well, the first result was no good, but like we were saying that we didn't want to just take the first result, the most likely result, but rather we wanted to rank multiple results. Oh no, that's the opposite. We wanted to use it to rank multiple candidates that are provided by Jin. But anyway, what I wanted to do is just, okay, the very first most likely token is colon. I'm not happy with the very first. Can we look at the second? So instead of maximum by, we would use sort by, and then I guess we'd take the second entry in the list instead of the first one. So now it returns a list. So we can do it, do a map FST so that we get both.
No.
Just map FST dot. Or dollar, sure, yeah. So now we should have two words, colon and the second less likely. We could also like drop one to get only the word we're interested in, but we can ignore the colon. Let's run it.
Wait a minute. So this is now.
It was already a list of
Okay,
hints.
but if you do this, yeah, but if you do this, then we will get like a 50,000 character long response from the tokenizer. So I think we should say something here.
Okay. So add the drop, take two. Dot map.
Wait, let me just let me fmap over that thing. Maybe that's better.
Why? It's already taking a list. Previously, it was a list of length one.
Okay, so the thing is, if we treat this as one big list of tokens, then the tokenizer will try to interpret this as a list of, okay, so like decoding is not just decode each individual token individually, and then just like put them together, padded by spaces, or not. It's something that is actually not. It is not a functor, right? So like there's post and pre-processing going on in this decode function.
Well,
Therefore,
in
I
that
think
case,
we can't do it like that.
don't we have to decode the encoded version of Haskell concatenated with the encoded version of Colin instead of only decoding the encoded version of Colin?
Sorry, I didn't get that.
So we currently have a bunch of numbers.
Yes.
And you're saying that decoding this list of numbers is not the same as decoding the first number and then decoding the second number and then decoding the third number.
Yes.
And so I'm saying that if that is the case, we already fell prey to that false assumption earlier when we were asking, okay, complete Haskell mask, and it gave us a list of numbers, and instead of just instead of encoding this entire sentence, Haskell is something, we only decoded the something. So we already thought that we could only decode one number at a time. So maybe it's not Colin,
Yes.
maybe it's something else, if you decode it after Haskell.
Okay, I mean, it will still be colon, but maybe there's a space around it,
Okay.
or not.
If that's the only difference, then yeah, that's not better.
But okay, wait a minute. I wanted to do something. I'm now completely confused because so what I want to do is I want to basically run the tokenizer on each entry individually, and I'm totally confused right now.
Loop
So, wait a
over
minute.
each
So each of
entry
these
in last
produces
logit and construct a singleton list.
Can I just do traverse?
Not quite. If you do traverse, then
There.
oh, yeah, that should work. So for each,
Let's see what. Well, I
element,
get still
it
50,000.
turns it into
Let
a
me see.
list, and then we call decode on each of them, and then we receive a list of 50,000 strings. Yeah, let's take that the first 10. Yeah, so there will be colon, something else, and hopefully one of those words is acceptable.
Okay.
Still backtrace.
Panicked unoptical tokenizer result to C string null error.
Haskell null error.
Haskell. Oh, wait a minute. So that means one of the tokens is the bad one, 50,108. I know that token.
Oh, really?
I know it very well.
Okay.
Yes, this one contains the null token, or the null character, which is used to terminate C strings. So this is like an adversarial token.
So it thinks that it's Haskell null as like the null character as one of the 10 most probable.
Yeah. So that just means it will not be. It will not be among the first 10. So I will just do the take 10 before I send it to traverse, so that I don't execute the tokenizer on all of these things.
Okay. It's not on the first 10. It's just somewhere in the 50,000.
Okay. Then I guess I'd say here take 10 of those, and then I don't need to take 10 here. Actually, I don't know how to work around that stupid token, because I discovered it during unit testing, and then I looked into alternatives of like how to use C strings, like the Haskell foreign C FFI functions. They actually have a function that allows you to construct C strings that are length
Mm-hmm.
delimited, not 0 character limited.
Mm-hmm.
But Rust seems not to be in favor of those. Um, so I don't know how to handle that. Seems like there's a bit of a lack in functionality. Anyway,
Weird.
so we're back to where we started.
Okay, so moment of truth again. Timestamp.
No way again?
It's among the top 10.
Oh. I guess I have to filter it then.
I guess.
I'll just go back and kill that
Instead of
person
filtering
again.
it, can you like special case it and print null so that like we know at which position it thinks that null is the most likely character to follow Haskell in its data set?
Sorry, what was that? I didn't quite get what you meant.
Well, you said you want to filter it out, and if you filter it out, we will get like the first 11 most likely words except for null. And we will never know at which of those 10 positions null was. But if you, like in your traverse function, if you check, okay, is the number equal to 50108? If so, return null, otherwise call the code, then we'll know.
Oh, I see now what you mean. Okay, yeah.
And if we were on VS Studio Code, I could just have typed it, but I guess we found the downside of this arrangement.
Right. I don't even know how to do that in Haskell. Wait a minute. So, like, I want actually. Well, I could use case, I guess. 50,000. 50,108. Not that often that I need to case split on values like that.
Mm-hmm.
Pure boom. Otherwise, do that, I guess.
Mm-hmm.
Other cases. Next. Oh. Okay. What by? Okay. Try this again. Hopefully this works now. Mm-hmm.
Haskell percentage parenthesis dot. Where's Colin?
What? Where's Colin? Yeah.
Haskell.
Oh, where's
quiz.
Boom?
Yeah. Yeah, this is not working.
What the heck? What's going on? I don't understand. So wait a minute. So we have sort by.
Oh, sort by.
comparing
So we have
second.
the least likely first.
Oh, okay.
So, you can use down down.snd in order to compare in the opposite order.
Wait a minute, just a sec. Pure. Okay, this returns
So
IO string. This is an
backslash
IO
0, the character is in the 10 least likely cases, not the 10 most likely cases. So that we've at least got that.
Okay, but like I don't. Okay, but like why is 50,108 not among those?
Oh, that's true.
It almost seems like that the order is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's still 10. So there should be boom among them, but it's not. Anyway, so how do we turn this around?
Yes,
sort
so
by
comparing takes as an argument a function from the things that you are comparing to a value that has an ORed instance. So SND is currently bringing it from a pair to a float. You can bring it from a pair to a down float, where down is a new type wrapper that flips the ordering. So comparing down.snd is going to compare.
Can I just like say second.negate or something?
Not quite. So one reason, negate will work too, actually, yeah.
Okay, so like, but this other thing I'm not familiar with, so maybe I want to try that. So I do it like this.
Down.
What was the wrapper?
Down.
Like this?
Yeah. So negate takes advantage of the fact that you know that if you negate both floats, they will compare in the opposite order, whereas down is more generic than that. If you have an arbitrary type with an ORed instance, it compares them using the existing ORed instance, and if it got LT, it returns GT and vice versa. And so when you said negate, I was thinking that, oh, okay, you probably want to do that same thing, but like after comparing is called, but like negate is not a function that you can call on LT or GT, and it took me a while to catch up on the much more obvious thing that you wanted to do.
Okay. So the linter suggests not using this construct by sort on down.second. I guess you said something about comparing being.
Yes, so earlier when I was saying maximum by comparing, I was saying, oh, there might be a maximum on version that shortens this idiom. Clearly there is one for sort. Sort on something is short for sort by comparing something. So yeah, we can certainly do that simplification. But it's not to remove the down, it's to remove the comparing. So I don't know why your linter did not see this before.
Good point. Okay, let's just ignore this.
Haskell colon. Haskell is a language, we know that. Haskell has grown in popularity. Haskell's excellent type system, Haskell and other similar languages. Haskell has lots of cool features. Haskell 65533. What's that Unicode symbol?
Okay.
6, 5,
so
5,
I guess the
3,
is was not that bad. I mean, we could. I mean, we
Haskell
already tried colon. We could.
Haskell dot.
Let me try colon, and see what comes after colon. I mean, after. I don't understand why it doesn't say curry. I was expecting curry.
Oh yeah, that's a good one. Ah, that was so disappointing.
I-
All 10 are sad. What are those? Haskell, colon,
yes,
I,
D,
Haskell.
what?
Yeah. Haskell, colon, the best imperative language or something. Haskell! No.
Okay, okay. All right. I guess next time we could actually write that greedy search. Should actually be quite fun.
Yeah. Yeah, let's do that next time. We've spent way enough time today. And with such a a result that I wouldn't say anticlimactic, but like it's not at all what I expected. Such a surprising result. It's so positive anticlimactic. Haskell, no. Or Haskell.
So I guess when I say Haskell colon, it's kind of like in a play where Haskell is one of the protagonists.
Oh, I see.
Let's see what happens if
It finds it more often in a play than in documents that talk about Haskell the language.
Maybe more like a chat protocol, perhaps, than a play. I don't know how many plays this thing I've seen. So I just expanded with I. Okay, I don't. I guess. I have can thing was I guess this seems to be from a chat.
Yeah, so we won't get something interesting about the Haskell programming language when we implement the thing that looks at all of the words until the end of sentence, but it will still be a useful thing to work on. Yeah, let's do that next time.
Cool. All right, that was fun.
Yeah, it was a long hiatus, but now we'll go back in 2 weeks. So.
Cool. Indeed, yeah.
See you then.
Let's do that.
Ciao.
See you then. Bye.